Okay, welcome to another Ginger Mathematician video. So we are going to go through the modelling section of the paper 6.1 November 2019. This is a 0607 paper. So before we start, please subscribe, please press that like button if you like this content. Not much mathematical modelling out there, particularly for the 0607 paper, as it can be quite tricky. So let's get started straight away. So let's give a bit of context to what we're doing. It's about when plants flower, and depending whether it's dark outside or light outside affects when the plants flower. And as we probably all know, the number of hours of darkness plus the number of hours of daylight, they're always going to add up to give us 24, because there are 24 hours in the day. And we've got a start of a graph of the hours of daylight in Normandy, France, 2017. Notice the scale goes up to 24 because this encompasses 2 years. Yeah, so 12 months in a year, so 2 years. And the pattern remains the same each year, and we need to complete the graph. So we need to repeat this same shape for the next year. And the way we do this is by noticing our maximum point here, for example, at 16. This is at July, so we need to do the same thing here as well for 18. So that's going to be our maximum. It's going to be the minimum point, the lowest point at January. So we're going to select January here as well. And then we're going to make the same smooth curve, or at least try and make the same smooth curve on a computer. So here we go, up we go. Okay, not so smooth, but I'm sure at home you can certainly make that a smoother curve. Now on the same grid we need to draw the graph to show the numbers of darkness for the 2 years. So let's have a think. When it's 8 hours of daylight, there's going to be 16 hours of darkness. Likewise, when there are 16 hours of light, there's going to be 8 hours of darkness. So there's always going to be this alternating pattern like so. So we need to make sure we've got this all lined up, and we're going to draw the same kind of curve, but notice we've essentially flipped it around. So I'm going to try and draw as well as I can. A bit tricky on a computer, but I think that's not too bad. That's a little bit strange in the middle, but otherwise you see the effect that's going on. And we want to describe fully the single transformation that maps the graph of the number of hours of daylight onto the graph of the number of hours of darkness. So what the question's asking, how do I go from the red graph to the blue graph? Well, we can see there's a reflection going on here, and the reflection is occurring at the middle point, so to speak, between our two graphs. That is when the number of hours of light and dark are the same. So we have an effect of reflection. And this will be in the line. And we call this line the line y equals 12, because in every coordinate of that black line, the y coordinate is always 12. So we need to write for the 2 marks the reflection and the idea that the line is the y equals 12. Now Pierre himself, there's the mark scheme if you want to have a look at it. Pierre grows oats in Normandy, France, and oat plants flower when there are less than 12 hours of darkness. And we want to find the earliest month where this occurs. Now if we look at our graph, now I've drawn a black line here so it makes it less visible. But you'll see that at 12, the graph is just before this line here, if I circle it. So it's just before this line here, which represents April. So right at the end of March, it crosses that threshold of more than 12 hours of daylight, i.e. less than 12 hours of darkness. So our answer here is going to be March. So we write down March on here. Okay, now at this point we're actually given a model, which is very, very nice. Could have given us it earlier, but never mind. And you see the model here is a sinusoidal model, so it's using sine here to represent this situation. where X represents the start of each month. But notice January doesn't start at 1, it starts at 0, which is why December is at 11. And using that model, we need to find the maximum number of hours of daylight and the month in which this occurs. Now, the way we do this, so we need to use our GDC, so this thing here. Make sure you always have it ready for the modelling aspect of the Paper 6 exam. And what we're going to do is we're going to draw a graph. So we go to the On button, New, and we want a graph. And we're going to type this function in with one thing to watch out for. So open brackets, 30, open bracket, x minus. Now this is important here. If we just type in 2 and 20 over 31, like it is in the question, what the calculator will do is do 2 times 20 over 31. So what we need to do before we type it into our calculator is actually convert this into an improper fraction. So we do 31 times 2, that gives us 62. Then we need to add on the 20 and then divide by the denominator. Otherwise your calculator will get confused. So we need to write this in as 82 over 31, not 2 and 20 over 31. So this is why I'm doing this step. So let's get the calculator. We're going to create a fraction, like so, and then we're going to add on some brackets, hopefully not too many brackets. We press enter, and we don't see a graph. And we go, we're panic in the exam. But not to panic, there is a great function on TI Inspire. We can press menu, we press window zoom and zoom fit, and it will find the graph for you, which is very, very useful. However, we want to go between 0 and 11, like I mentioned here. So we're going to do a little bit of tweaking. We're going to go to Menu, Window, Window Settings, and we're going to go between 0 and 11. Press OK. And now we get a graph that we can work with. Now, Pierre wanted to, the model. From the model, we need to find the maximum number of hours of daylight and the month in which it occurs. So this is a function you need to know for your GDC. We go to Menu, we go to Analyze Graph, we go to Maximum. Now you see the maximum's up here somewhere. We need to tell the graph where to search between. So we click before the maximum point and we click after the maximum point. And you'll see we get then the two values we need. So we write in for the maximum 15.9. Now we could have worked that out without a calculator because sine always goes between 1 and minus 1. So the maximum for any sine function is 1. 1 times 3.9 is 3.9 and 3.9 plus 12 is 15.9. However, the month would be much more difficult to work out. Now we don't need the exact value here. It's 5.645. I'm going to write that down. And let's see what month that corresponds to. Well, that's going to be in the month of June because it's above 5. So we write it in. Okie doke. And Pierre thinks his oat plants flower at their best when the number of hours of darkness is at its minimum, and we need to find the minimum number of hours of darkness. Well, we could do some extra GDC work, but it's not necessary. We know the maximum hours of daylight. So if we take that away from 24, because there are 24 hours in a day, that will work out then the minimum number of hours of darkness, because darkness plus daylight hours always have to add up to 24. So we do 24 minus 15.9, and we get 8.1. Okay, and now using Pierre's model, we're going to write down the model for the number of hours of darkness. Now think about what we looked at right at the start. This graph here. Notice it was a reflection, wasn't it? There was a reflection between the hours of daylight, and if we reflect that graph, we get the hours of darkness. Now the way we reflect a sinusoidal model, the way we do this is instead of having a plus here, we just put a minus instead. So we're going to copy across that model. The only thing that's going to change is we're going to put a minus there instead. Now the difficult part, of course, is remembering everything else that's in the model. So we've got 30. That's it. And then open bracket, x minus, was it a minus or a plus? That's kind of important, minus 2 and 20 over 31. Okay, this is related to when you do this f of x notation. What we're essentially doing here is we're working out minus f of x. Okay, if you're not sure what this means here, then please do revise. Transformations of graphs is on the 0607 course. And now we need to verify something. On the 20th of March, the number of hours of darkness is the same as the number of hours of daylight. And there are 31 days in March, nice to know. And show that Pierre's model finds this date accurately. So, when the hours of darkness is the same as the number of hours of daylight, then they're both going to be 12. So, we need to go back to our GDC. Okay, we press the tab button, that allows us to make another function. We type in 12. That gives us a straight line. And now we need to find the intersection point between the two graphs. So we go to menu, we go to analyze graph, we go to intersection. And the calculator still needs to scan between the lower and upper bounds, i.e. we need to click before the intersection, and we need to click after the intersection, and then we get this decimal of 2.645161. So we're going to write that down. I wonder if I can just use draw here, might be easier. So we get 2.64561. Now we need to show that that corresponds to the 20th of March. Well, the 2 represents March, so we need to show that this decimal gives us 20. So the way we do that is we take our decimal, 0.645161, and we times it by the number of days in March. Now, luckily we're told this, there's 31 days in March, so we make this calculation. So we know it's in March already because of the 2. If I just quickly go back, see March represents by 2. And if we work out this, so 0.645161 times 31, we get, calculator almost got there, 19.999. It's quite a lot of 9s here. Okay, which is basically the same as 20. So we then confirm that it's going to be on March the 20th when the hours of darkness and the hours of daylight occur. Okay. And to quickly show you the mark scheme. So March, 15.9, June, 8.1, did it the same way that I did. Notice the darkness model is just the reflection, there's where the minus comes from. And x is equal to 2 and 20 over 31. I worked out as a decimal using the GDC, and then we showed that that was the same as the 20th of March, 20 out of 31. Okay, so we go on to question 5. So Alexa, she grows soybeans in Queensland, Australia. In Australia, there are more hours of darkness in June than there are in January because they're in the southern hemisphere, not the northern hemisphere. And Alexa records the number of hours of darkness of 360 days from the 1st of January to the 26th of December, and she finds the following information. So the hours of darkness, we've got a maximum and minimum, and she wants to use a cosine model to represent this, where t is the day of the year. And we want to write down suitable calculations to show that a is equal to 12 and b is equal to 1.8. So let's think about a cosine model for a second. So a general cosine model, we're going to take the positive version, goes like this. Okay, so you start at 1, it goes down to -1, then comes back up again, and the middle point is 0 here, yeah? So this is our line of rotational symmetry, so to speak. So notice it goes between 1 and -1 here. Okay, so this is always halfway between this point and this point. Now, in the model that we're given here, let me use a different colour, we've got instead 13.8 and 10.2. So the middle point of this graph is going to be halfway in between. So the way we work out halfway in between, 13.8 plus 10.2 divided by 2. So if we do that on a calculator, okay, of course, use BidMath, of course, that would also help. So 13.8 plus 10.2 divided by 2, and that gives you 12. So with the same idea here, this whole graph then, to get up to 10.2 and 13.8, has been shifted up 12 units, yeah, in order to have the equal distance between here and here. Okay, another way of thinking about it, I've got 10.2 as my minimum point, I've got 13.8 as my maximum. I want to know what goes in between, that's going to be 12. Normally, with a cosine graph, it's 0, so we need a 12 shift upwards, so our A is going to be equal to 12. Now, once we've established that the middle is 12, okay, this part here, this is going to represent the amplitude. So the amplitude is essentially the distance between 12 and 13.8. So this distance here. And if we do 13.8 minus 12, we'll actually get the value of 1.8. Okay, I mean, this could be worked out by just doing 13.8 minus 10.2 and then divide it by 2. That would also give you the answer of 1.8. So B is equal to 1.8. Now, if I show you the mark scheme on this, you'll see that they calculate it this way. Yeah, so to work out A, you just add together the maximum minimum and divide it by 2. That finds you where it is in the middle. And B is, okay, I want to find the distance between these 2 points, the maximum minimum, and then divide it by 2 to find out half of it, which represents then the amplitude. Okay, so we then get our values of A is 12 and B is 1.8. Now, our next part of the question is to type this into our GDC. Notice that we need the x scale to be between 0 and 360. So let's go back to our GDC, like so, and we're going to start a completely new document. And before we start, I'm going to change the window settings. So x is between 0 and 360, because that's what they want in the question. And now we type in 12 minus 1.8 cos. I can type in cos. You can also use the trig button here to give you cos. And we need to work in x because our variable here is an x. And if we press enter, we go, where has the graph gone? But again, don't remember, we've always got this function of zoom fit. And so we can actually find the graph and it will adjust the y scale accordingly, okay, to help you visualize what's going on. So we're going to sketch the graph. Now, I know it doesn't say this strictly on the mark scheme, and it is a 1-mark question, but what can be useful is just stating what the y-intercept is. Now, there's a couple of ways you can do this. I'm going to show you something different. There's a trace button here and graph trace. And what you can do with trace is it will mark on various different points. So we might need to use this later on. This is the maximum. So it will label things as you go along. What I just want to label here is the y-intercept. So the y-intercept here is 10.2. So when I draw my graph, I'm going to mark on 10.2. And then I'm going to draw the shape of the graph like so. Hopefully you can do it smoother. And if you want bonus points and communication marks, which we'll talk about at the end, you can actually mark on the maximum point 2. So I think that was 13.8, but we can go back and check. Again, we can also use the function for maximums, analyze graph. Maximum, scan before, scan after, get 13.8. For our y value. And let's just quickly check our x value. Was 180. Okay, so halfway in between. Makes sense, symmetrical. So we pop that in, 180. Okay, as you see in the mark scheme, they just want the correct sketch. They don't even actually ask, if I zoom in on this, for the y-intercept per se. They just want the correct sketch and the correct shape involved. Okay, and soybeans flower when there are more than 12 hours of darkness. The flowers grow at the fastest rate when there are 13.6 or more hours of darkness. Find the number of days when the flowers are growing at their fastest rate. Okay, so no soybeans grow better in darkness. This is one thing to consider. So notice our model, okay, I should have mentioned this earlier, models the number of hours of darkness, not daylight. So we want to find when it is 13.6. That's what's given in the question. So we go back to our GDC. We're going to press the tab button. Allows us to create a new function. We type in 13.6, and you'll see it crosses the graph at 2 points. I'm going to move this maximum out of the way for the moment, and I'm going to find the two intersection points. Number 1. We'll move that to the side so you can see what's going on clearly, and then analyze graph. Intersection number 2, and you'll see these two values. So let's write those down. We'll stick with red. So we have 207.266. That's when it's coming down from its darkness, and 152.734 when it's coming up. And what we want to find is the number of days when the flowers are growing at their fastest rate. So what the question is looking for is the difference between these x coordinates. How long does it stay above that line? So we take those two numbers and subtract them. So if we subtract those numbers, 207.266, 152.374, we then get 54.892. Okay, and yeah, as long as you write something within the range of 54 to 56, I'm going to round this up to 55 days. Okay, and there's our answer. So 55 days. So in this case, it's looking for the range between two values between the two intersection points. Okay, and you can see you get method mark for writing down these two values as well from your GDC. Okay, let's keep going. Try and keep it to the amount of time you'd have in the exam. And the table shows the value of t on the first day of each month. So given us as on the board, as you can see. On average, Alexa's soybeans flower 53 days after she plants them. And she wants to plant them so that when they begin to flower, the flowers grow at their fastest rate, i.e. they stay above that line that we looked at. Use Alexa's model to show that the latest date she should plant her soybeans is the 3rd of June. So we need to look at the end of our graph. So if we look at the end, it's 207.266. So she needs to plant it 53 days before that. So let's work that out. So we've got 207.266, I think that was the number. That's the latest before it goes below that line. And we minus 53 from that. So if we do that calculation, 207.266 minus 53, we get 154.266. So notice June the 1st, is equivalent to 152. So it'll be during June the 3rd when it would dip below that line. Because June the 3rd, if we count on 2 from 152, gives us 154. So it'd be June the 3rd is the latest time you can plant them. It's because 53 days after that, it will then dip below that line that we just indicated. You can see the questions get a little bit more subtle at this end of the paper. Okay, and there's the mark scheme, so same calculation that's given here. Okay, and we're coming to our very last part of the paper. So Alexa uses her model 12 minus 1.8 cos t to find the first date when the number of hours of darkness is the same as the number of hours of daylight. Find this date. So again, it's a similar process to what we did before. So if I zoom out, go back to my GDC like so, we're going to again look for that line of 12, because again 12 hours of daylight is the same as 12 hours of sunlight. It's the same amount of time. So I'm going to do another line. So I'm going to press the tab button, 12. Notice you get another line here. We're going to again do our analyze graph like we did before. Intersection. Now we need to choose the graphs that we want to find the intersection of. So we choose the blue graph and black graph. Click before, click afterwards. And you'll see that you get the value exactly of 90. So let's copy that across. So we get x is equal to 90. And if we go back to our table before, you'll notice the 1st of March is 60. So let me write this down nice and clearly. That March the 1st is equal to 30. So if we add if we add 32, sorry, add 32 that, sorry, that was 60, apologies. So March was 60, sorry. I want to add 30 to it, sorry. Yep, let's go through. So March 1st is 60, so we add 30 to it, we'll then get to 90, which will be then March the 31st. Okay, so we get March the 31st. Because x was 90 from the graph, we know March the 1st represents 60 from the table, and so if we add 30 to that, which will get the 90 value, that will be the same as March the 31st. Okay, and the actual date when the number of hours of darkness was the same as the number of hours of daylight was the 20th of March. It wasn't actually the 31st of March. And we need to decide to change the model so it finds the date accurately. So let's copy down the model. So y equals 12 minus 1.8 cos t. And this takes a little bit of thinking about here. We want to change this model so it finds the date accurately. So what we want to do, instead of the number of days, of hours of daylight and darkness being the same on March the 31st, we want it to be the same on March the 20th. So what do we do to 31 to get to 20? Because that's the day that we want, where we want to take away 11. So what we want to do to this model is we want to shift it 11 units. Okay, and we want to shift it 11 units to the left. Yeah, we want to shift it this way. Now remember, within sinusoidal models, in order to shift leftwards, you need to add 11 within the bracket, so the opposite of what you think. So our transformed model is y equals 12 minus 1.8 cos, and we need plus 11 to go into the graph in order to get that shift. Now let me show you on our GDC why this actually works. So if I go back to my GDC and press tab and go to our initial function, if I put plus 11 in here, watch what happens to my intersection points. So if I put plus 11, notice we actually do shift across and we do get, instead of 90 being there, we get 79, which is exactly what we want because we actually want to shift it across so that it actually hits at March the, let me just open it up. We actually want to hit that at the date that was given, the 20th of March. And that's given when we can actually put plus 11 into our model. So if you just show you the mark scheme here. So 31st of March I already showed before, and you'll get the 2 marks, one for some value of k to indicate a horizontal shift or translation, and we need the value of k equals 11, because what do we do to 31 to get 220? Well, we need to move it in 11. Okay, and that will give you the 2 marks. One for the idea of something inside the cosine function, and then a second mark for k being 11. Now, in terms of communication, so on the old papers we used to get 1 mark for communication by doing 2 of the following things. So drawing the reflection line right back at the beginning. Long way away now. Drawing in this reflection line gives you a communication scene, so to speak. There we are. Okay, so drawing in that line. Writing in 5.6 scene or in the sketch. So let's go back to C part 1. Okay, so 5.6, which I wrote down there. So because I've shown 2 of those already, I would get the communication mark just by these 2 points here. Having a vertical scale to 13.8 and making that indicated. So that was showing the maximum point, for example. Showing y equals 13.6, which I did. I showed the y-intercept. And showing t equals 90 as well. If you show any of those things, or 2 of those things, then you gain the extra communication mark you need to get full marks on this section. Okay, hope you enjoyed the video. It's the first time I've done a modelling video, so please like, please subscribe, and please mention any improvements in the comments. A little bit tricky towards the end, but again, the more practice you do of these papers, the better it will be. All right, bye-bye for now.